One nice feature of R is the ability to do mathematical annotation within the plotting device. So you can make plots that have mathematical symbols in them to annotate them and provide context. So if you're familiar with the language, with the typesetting system known as LaTeX, then you have the ability to produce LaTeX-like symbols on a plot for doing mathematical annotation. So this is very useful if you want to make fun of other people who use other statistical packages, because they, generally speaking, don't have the ability to add LaTeX-like symbols onto their plots. So if you want to make a plot that's a lot nerdier than those plots, then this is the way to do it. So the basic idea is that math symbols are expressions in R, and so you have to use the expression function to encode them when you're using them in a plot. So there's a specific list of allowed symbols for plotting mathematical annotation, and they're documented in the help page for plot math. And so if you're interested in doing this kind of annotation, you should really look at the help page for plot math and basically have it memorized, because it's not very long and there are not that many symbols. So you can have it in your head and then do all the mathematical annotation that you want. So plotting functions that take arguments for text, so like the title function, the axis function, the text function, all these functions that take arguments that put labels on the plot will generally allow expressions for the math symbol. So while you can pass regular text to be plotted on the graphics device, you can also pass it an expression that will be translated into a mathematical annotation. So here's a simple example. Here I'm just plotting. I'm not plotting any data, but I'm setting up a plot window where the title of the plot is going to be the expression theta equals 0. The y label is going to be the expression gamma hat equals 0. And the x label is going to be the sum, so you can think of the capital sigma representing the sum, where I goes from 1 to n of xi times yi, the product xi times yi. So these expressions will appear in the plot window and will be typeset in a LaTeX-like manner. You can also paste strings together. So for example, here I'm creating a histogram where the x label is the expression the mean, and then in parentheses x bar is, and then the sum, xi over n from I goes to 1 to n. So here is just defining what x bar is, which is the mean. So you can paste strings together like this, which include standard text plus mathematical expressions. However, when you do this, all of it must occur within the expression function. So one question is, so in the previous example, I put hard-coded just constants into the labels that I wanted to plot on the graphics device. But what happens if the expression that you want to plot is actually the result of a computation? For example, suppose you want to say that the mean x bar is equal to, and then the mean of your data. Well, you're not going to know what the mean of your data is until you calculate it, and so you might want to put the actual calculation of the mean into the expression itself. So here I'm generating some data that have a linear relationship, x and y, and I want to plot x and y. And on the x-axis, I want to have the x label be the mean of x, and on the y-axis, I want to have the y label be the mean of y. So of course, I don't know what those numbers are until I calculate them. So I'm going to use the substitute function to pass rather than the expression function, because the substitute function will substitute the actual value of the mean into my plot. So here I'm saying that bar of x, so this is going to be x bar, is equal to k. And then for k, I say I pass the list k is equal to the mean of x. And similarly for the y label, I say bar of y, or x bar, is equal to k, where in this case k is equal to the mean of y. So now what substitute's going to do is it's going to take k, and it's going to substitute in the actual value of the mean of x for the x label and the mean of y for the y label. And so when I call this plot and direct it towards the plot window, on my y label and my x label, I'm going to have the mean of each of those dimensions. So and this is the example down here. I've got 4 plots that I'm trying to make in a 2x2 matrix, and I've got a little for loop here that's making the plots. And what I'm going to do is I'm going to create a histogram of some randomly generated data, and in each histogram, I want to put the title to be theta equals a number 1, 2, 3, 4. So here I'm just substituting I'm using a substitute. I'm saying theta equals num, and then num is going to be equal to I, which is the index in the for loop, which is going to be 1, 2, 3, and 4. So you can see the result here is that I get 4 plots, and the title for each one is theta is equal to 1, 2, 3, or 4. So this is just some of the mathematical annotation that you can do in R. You can get a lot fancier if you want to. And looking at the plot math help page will allow you to see what kinds of symbols you can put into your plots. So just a very quick summary of the important help pages that are useful to know when you're doing plotting in R. The par function definitely you should be looked at to look at all the different options that you can specify in the base plotting system. The plot function, of course, is quite useful. In the lattice system, the XY plot function, it has pretty much all of the help information that you're going to need if you use the lattice system. The plot math help page is useful for if you're doing mathematical annotation, and it is actually relevant to both the base plotting and the lattice plotting system. So you can do mathematical annotation in both systems using the same approach. And finally, the axis function is actually quite useful for the base plotting system if you want to annotate axes in special ways.